Hi everyone, welcome to Jerematics Tutoring. In this video, I will be teaching you about the applications of the sine, cosine, and tangent ratio to the Cartesian plane. Before going any further, I want to give you a quick recap on our sine, cosine, and tangent ratio and just make sure that we're on the same plane over here with all of these ratios. Just so when I refer to the sine ratio, you remember what the sine ratio is equal to. Well, the equivalent of sine theta is opposite over hypotenuse. So this means that your sine ratio is the opposite of your angle divided by the hypotenuse. That's the ratio, and the angle itself is with the sine. And then the cosine ratio is the adjacent over the hypotenuse, and the tangent ratio is the opposite over adjacent. And remember the acronym to remember this is SOHCAHTOA. S sine, O is opposite, H is hypotenuse, C is cosine, A is adjacent, H is hypotenuse, T is tangent, O is opposite, A is adjacent, SOHCAHTOA. That's just a way to remember all these ratios. In this video, I'll be showing you about how all of the stuff I've been teaching you so far in this playlist all connects back to each other and is actually able to be used to be able to apply trig ratios to it. So the first example I'm going to give you is we're going to be doing something called finding exact values. And what this means is when you find your trig ratio is you don't round it. You leave it as like a fraction. And if there's radicals, well, you leave the radicals there. And then if you need to rationalize it, then you rationalize it. But in this video, I'll be keeping it very basic. And I will give you an example involving one radical, where you got a radical in your answer. So you never represent your answer as a decimal. You just leave it as a fraction. The first example I'm going to be giving you is more of a general example, because I want to give you this general example first, so we're actually able to find a general formula for sine, cosine, and tangent. So, and this formula can be applied to the Cartesian plane. Like, it's really the same formula, except it's just different letters, because on the Cartesian plane we're dealing with x, y, and our hypotenuse rather than our opposite. And really, it's the same thing, but it's just different letters. And really, it's actually pretty easy to remember in the Cartesian plane because there's 3 letters, right? Here, it's just really the same thing. So we have a terminal arm that passes through point xy. Where am I going to draw point xy? Well, I could really draw it anywhere, but to keep it pretty simple, I'm going to draw this in quadrant 1. Quadrant 1. And I know you're seeing this ASTC thing on the board right now. I'm going to talk about that in a moment, but for now I'm going to give this example with the triangle. So here we got our point xy, and here's x, y, and our hypotenuse, okay? And there's no like set value for hypotenuse because we don't even have a set value for x and y. And our hypotenuse depends on our value for x and y. And the general formula for hypotenuse is r is equal to the square root of x squared plus y squared. I know you're used to seeing r squared is equal to x squared plus y squared, or c squared is equal to a squared plus b squared, but another way to write the Pythagorean theorem, like if we're just solving for c, it's c is equal to the square root of a squared plus b squared. So really it's the same thing going on over here. Rather than squaring all of our numbers and then solving for r, well, we just solve for r right away and we take the square root of these 2 numbers added to each other squared, right? Well, the numbers are squared further added. Got a point xy over here, and here's our r, and where's our angle? Well, of course we have a right angle right here, but that's not the angle we're trying to find. Remember that when we drew arms in, when we drew angles in standard position, we had 2 things: an initial arm. Our initial arm is right here, and then our terminal arm is our hypotenuse, really. Our terminal arm is right here, right? It's this diagonal line over here, and it was that terminal arm that decides what our angle is. So the angle that's formed that we're trying to find is the one right here. It's the one that's formed between the terminal arm and the initial arm. That's always the angle that we're talking about when we're talking about standard position, the Cartesian plane, and everything. So here's our angle theta. What do we do this now? Well, since we have theta, we have our angle theta right here, so we know that we're trying to find angle theta. We got our x, y, r all figured out. Now what we need to do is we need to find our sine ratio of this angle, we need to find the cosine ratio of the angle, and we also need to find the tangent ratio of the angle. Well, how do we start? I'm going to start with the sine ratio. And remember that sine is equal to the hypotenuse, the opposite over the hypotenuse. Sine is equal to opposite over hypotenuse, y over r. Opposite over hypotenuse. Y is the hypotenuse, it's the height, and r is the hypotenuse. So we can replace our OPP, and OPP stands for opposite, not Ontario Provincial Police, stands for opposite. So opposite, we replace that with y, and our hypotenuse is r, so we put a y over r. Now for our cosine, remember that cosine is the adjacent over the hypotenuse. And remember that adjacent is the leg that's connected to your angle that you're trying to find. That's not the hypotenuse. That's how I remember it. It's always the leg that's connected to your angle, and it's not the one that's the hypotenuse. That's x over r. So the adjacent over hypotenuse is x over r. So far we got that sine theta is equal to y over r, and y over r is the exact value of our sine ratio. X over r is our exact value of our cosine ratio. And what about the tangent? Remember the tangent is opposite over adjacent? Well, what is the opposite over adjacent over here? We got our y and we're dividing it by our x because opposite over adjacent, y over x. So tangent is equal to y over x. Y over x. So once again, sine is equal to y over r, cosine is equal to x over r, and tangent is equal to y over x. As you can see over here in the Cartesian plane, there's something over here that says a, and there's a plus, and it says sine, cosine, and tangent. What I mean over here is, in quadrant 1, all of our trigonometric ratios are positive. Why does this really matter? Well, we need to remember which quadrant, which trig ratios are positive, so that when we find exact values, we know if our exact value should be negative or positive, because that makes a big difference to our final answer. For example, if your tangent ratio should be 1/2, and you get negative 1/2 instead, or it should be negative 1/2, and you put 1/2, well, your answer is wrong, because it's not the same thing at all. Quadrant 1, all trig ratios are positive. Why is that? In quadrant 1, this is where all of our x coordinates are positive because it's the positive side of the x-axis. And in quadrant 1, all of our y coordinates are positive because it's the positive side of the y-axis. So in quadrant 1, all of our coordinates are positive, just like it normally would with the Cartesian plane. So what this means is our x is positive, our y is positive, and our r is positive. And if you're dividing all positive numbers, well, you'll always get a positive. And if you do get a negative in quadrant 1, please leave me a comment below on YouTube because I'd be quite interested in knowing how you got a negative in quadrant 1. So it should always be positive. Quadrant 2, only sine is positive. Why is only sine positive? Well, if we look over here, remember that in quadrant 2, our x coordinates are negative because this is the negative side of the x-axis. So what this means is that since the x's are negative and our y's are positive, well, that means that x is negative, y is positive, and r is positive. So if we got any x's involved in our ratios, well, we'll get a negative. Sine does not depend on the x value, really, because sine is equal to y over r. And what this means is that since our hypotenuse is positive and our height is positive, our y value is positive, then we'll get a positive number, so sine is positive. What about for cosine? Cosine is equal to x over r. And remember that x is negative. So if we divide a negative number by a positive number, then we'll get a negative number. So that means that cosine is negative in this quadrant and it's not positive. What about tangent? Y over x. Y is positive, x is negative. Divide a positive by a negative, you're going to get a negative. So tangent is negative. The only trigonometric ratio in this quadrant that is positive is sine. Of course, there are more trigonometric ratios, but in grade 11, we only talk about these 3. And then in grade 12, we talk about 3 other ones, which is reciprocal trig ratios. I'm not going to talk about that right now, but you'll see in grade 12 what all these ratios are about. They're actually pretty cool. Quadrant 3, only tangent is positive. Why is that? Well, let's take a quick look at this and let's think about it. Quadrant 3, x's are negative, y's are negative, and our hypotenuse is positive. Sine, y over r. If our y is negative and our r is positive, you divide a negative by a positive, you're going to get a negative. So that means sine is negative in this quadrant. Cosine. This is x over r. Our x's are negative in this quadrant, and our r is positive. What do you think you get when you divide a negative by a positive? You get a negative. Cosine is negative. So sine and cosine are negative. What about tangent? X's are negative, y's are negative. Tangent is equal to y divided by x. So if y divided by x is equal to two negative numbers divided by each other, well, you're going to get a positive because a negative divided by a negative is a positive. So that means that tangent is positive in this ratio. So that's why only tangent is positive in this ratio. Quadrant 4, cosine. Only cosine is positive in this quadrant. Why is that? Well, sine, y over r. Is y positive or negative in this quadrant? Y is negative. X is positive in this quadrant, the hypotenuse is positive. So what this means is that since x is positive, y is negative, and the hypotenuse is positive, well, anything involving your y will have a negative as a result. So for example, sine, y over r. We divide a negative by a positive, we get a negative. Sine is negative in this quadrant. What about cosine? X over r. We divide a positive by a positive, we get a positive. That's why only cosine is positive in this ratio. Well, what about tangent? Y over x. What's y divided by x? Well, a negative divided by a positive gives you a negative. So that means that tangent is negative in this quadrant as well. The only one that's positive is cosine. A good way to remember this is the acronym ASTC. And this acronym is in order from quadrants 1 to 4 because 1, 2, 3, 4, ASTC. And we have all kinds of acronyms to remember this. It could be things like all students take calculus. That's the one that most math teachers use. But of course, the students know this is a big lie because not all the students take calculus. Most of them hate it, and they won't take it. There's other things like really anything that works for you. Like even Annie sweared today constantly because she was doing a math test. Like whatever works for you to remember things. It could be like really anything. Or even actually someone today cared. If I see somebody subscribe to my channel, then I'll say, oh, actually ASTC. Actually someone today cared. So anything that works for you to remember it. I remember all students take calculus. And when I say that, I know people look at me funny, but that's how I remember it. So I'm going to give you two examples involving a given point, and then you need to solve for your exact values of trig ratios. So I'm going to leave the ASTC on the board, just so you see the entire video and it kind of sinks into your head. So the first example I'm going to be giving you is the point 34. So we need to find the exact value of our trigonometric ratios if our terminal arm passes through a point 34. So in the point 34, our x and y's are positive. So this means it's in quadrant 1. So 3, 1, 2, 3, 4, 3, 4. 3, 4. So we draw this triangle, and in the last video I showed you how to draw a triangle on the Cartesian plane. Remember that this is point 3, 4, the highest point if it's in quadrant 1 and 2, and if it's in quadrant 3 and 4, then the point that you're plotting will be your lowest point of your triangle. And here's our terminal arm, here's our initial arm, so here's our angle that's drawn, and now point 3, 4, what do we do this? Well, we literally write the number 3 down here because that's our x, and y's are 4, so 3 and 4. Now we need to solve for r, and remember that r is equal to the square root of x squared plus y squared. And this is actually one of the Pythagorean triples. So if we got a 3, 4, what's the hypotenuse? It's a 5, right? Because 3 squared is 9, and then plus 4 squared, which is 16. 9 plus 16 is 25. Well, I'm just going to write this out for you. R is equal to the square root of 9 plus 16. R is equal to the square root of 25, which is equal to 5. So the R is 5. So x is 3, y is 4, r is 5. They're all positive, so this will be a nice and easy example. Well, we need to find the exact value of sine, cosine, tangent. Which one do we start with? Well, let's start with sine. We'll start with sine. Sine is y over r. And what is y over r? Y over r is 4 over 5 because our height right here is our y, r is over here, x is right here. So sine is equal to y over r, 4 over 5. So sine theta is equal to 4 over 5. So that's our sine That's the exact value of our sine ratio. And what about cosine? Cosine theta is equal to x over r. What's our x? It's 3. R is 5, so that gives us 3/5. 3 over 5. What's our tangent ratio? Tangent is opposite over adjacent. So our tangent is 4/3. Well, tangent y over x, opposite over adjacent. But in Cartesian plane, we use y over x. So y over x, 4 divided by 3. So 4 divided by 3. So to repeat once again, if we have a question that states something like determine the exact values of the trigonometric ratios, sine, cosine, and tangent, if the terminal arm passes through point 3, 4, step 1, figure out which quadrant your coordinate is in. In this case, it's quadrant 1. So we draw a point 3, 4, the Cartesian plane, 3 units right, 4 units up. We connect the origin to the point we plotted, and that's our terminal arm. And then we plot our width, x, is 3, and then our height, y, is 4. Now we got a triangle. We solve for our r, which is the hypotenuse. We find our hypotenuse, and then once we found our hypotenuse, well, we sub in all of our values into our trigonometric formulas, trigonometric ratios, and this will give us the exact value. So sine theta, y over r, 4 over 5, cosine, x over r, 3 over 5, tangent, you get 4/3, opposite over adjacent, y over x. And that's how you find the exact value of trigonometric ratios. I'm going to show you one more example, and that will conclude this playlist. So the example I'm going to give you in this one it'll involve a negative, just so you can see what I mean by only sign will be positive. Because you must be wondering, well, like he did explain it, but is he going to give us an example? Well, I sure will. I'm not just going to leave you in the dark on a test. Don't worry. I'll make sure that you're ready for a test. And that if you do have to deal with a negative, well, you don't have a panic attack. Well, point negative 2, 3. Point negative 2, 3. So we got a point negative 2, 3. So we got a point negative 2, 3 on the Cartesian plane. Where does negative 2, 3 lie? Well, negative 2, 3 is over here. So here's negative 2, and here's positive 3. I'm just going to move this plus. So negative 2, 3. Negative 2, 3 is right here. So negative 2, 3 is right here. So that's negative 2, 3. We connect the origin to negative 2, 3. That's our terminal arm. And then after that, here's the base of our triangle, negative 2. And our height is 3. And what's our hypotenuse? Well, to find our hypotenuse, we use the formula r is equal to the square root of x squared plus y squared. So negative 2 squared, which is 4, plus 3 squared, which is 9, plus 9. So r is equal to the square root of 13. Can we simplify this further? No. So we'll leave it at square root 13, because the worst thing you can do is to give a decimal approximation for square root of 13, and then you solve all your trig values and say, yay, no, because you'll get the wrong answer, because exact values only involve radicals. So, well, exact values do not involve decimals. They only involve fractions, radicals, and so on and so forth. No decimals involved, because decimal is not an exact value, it's simply an approximation. Now we got negative 2 as our x, 3 as our y, and square root of 2 as our hypotenuse. Well, what do we do with this? Well, what we do with this is we do what we did in the last example. We plug in our y's, our x's, and our r's into our trigonometric ratio formulas, and we'll get our exact values for sine, cosine, and tangent. Sine theta is equal to y over r, and what's our y? 3. What's our r? The square root of 13. I don't know why I wrote 2. Square root of 13. So y over r, 3 over square root 13. And of course, we could rationalize this and multiply the denominator by square root 13, but I'm just going to leave it like this. Cosine is equal to x over r. Cosine, that's cosine. Cosine theta is equal to x over r. X is equal to negative 2. R is square root 13. So negative 2 all over square root 13. tangent y over x. That means tangent theta is equal to y over x, 3 over negative 2. So negative 3 over 2. And look, what do you know? Sine is positive, cosine is negative, tangent is negative. You see how the only one that came out positive was sine. That's exactly the result I expected. So this is how you find the exact values for sine, cosine, tangent ratios. I hope this video helped you. If you have any questions, feel free to leave them in the comments below. And if you like my content and would like to stay up to date, then feel free to subscribe.